The next challenge is MyCoolSDK. It says, I've written a program that lets you encrypt and decrypt strings, but it uses a proprietary closed source SDK through GitHub Actions. Of course, you can fork it, and only the magical GitHub black box will be able to see it. So there's no way you could dump the entire SDK, right? It says, note this challenge uses a non-standard flag format, irisCTF. After solving, please delete your repo. This is not a reversing challenge. Cool, so we're given a GitHub repo and a SDK. We can see this problem only has two solves by Strelick and I think it was Applet from UCLA. Again, I did not solve this challenge. I had to look at write-ups in Discord afterwards. I'm just going back through the challenges to solve them myself and make sure I really understand it. As far as I know, there's two solutions to this. There's the intended solution, which we're going to be talking about here, which is where you rename the repo. I think Strelick also said he was able to cancel the workflow halfway through with debug on and somehow get it to go through. I haven't tested that one. That was actually what I was testing during the CTF, but I couldn't get it to cancel at the right time. But it looks like he has the magic touch. But anyways, we're going to be talking about the intended repo rename solution provided by both Applet and Seraphim. Cool. So we get this GitHub repo and this SDK server source. If we look at the repo, there's not much here. There's this README, doesn't really say anything. It mentions again this cool SDK that we can't see. There's a program.c. Again, it includes this cool SDK, which we don't have. There's an encrypt function. Just takes some input, calls out to my cool string encrypt. There's a decrypt function. Again, just takes some input and then decrypts the code. And then there's a main function that asks if you want to encrypt or decrypt. So not too much going on there. There's a makefile. Cool encrypt. Again, it needs this SDK. It does some stuff. And this workflow file. So the challenge description mentioned it downloads this SDK, and then there's no way we can inspect the contents. And this is step 1, and this is step 2. If we look at step 2 all the way down here, we can see there's this make command. There's also it removes the SDK. Oh, it actually doesn't remove it. It just removes some unnecessary stuff. But here there's the final commands are to build this program. There's also something that makes downloads the SDK, and then there's a bunch of like token and identities and verification, and we see a website that belongs to the CTF. So it looks like, I think from this point we can kind of guess what's happening, which is this GitHub action runs, it does some identity checking of some sort, and then it downloads the SDK within the GitHub actions. And so these GitHub actions run on some worker machines within GitHub. You can install your own workers, but you have to change this file, and I'll talk about that in a bit, about why you can't do that. And yeah, once the worker's done, you can see logs, but you can't see the individual files, like you won't be able to see the contents here. And yeah, then I'll run make, and then everything's deleted. Cool, so like the challenge said, you can fork it. I already have it forked here. I made some changes. So at first I thought you could just modify this file, but you can't do that, and I'll talk about why in a second. But once you have it cloned, I mean, you just go back, sorry, if you don't know how to use Git, I think here there's usually a clone button, or it's here, I forget which one. Oh, sorry, it's not clone, it's a fork, and then it'll fork it to your repo, so you can start making changes. Then you can do a git clone, you can clone it locally. And so here we are, I'm in that repo, cloned locally. We were also given a index final, or a server SDK file. So that's this here. So this is the web server that the GitHub action is communicating to. And so these GitHub actions, they usually run when you like push to master or something like that. In GitHub, you can define actions for different things. And so that GitHub action is then talking to this server. So it does a couple different things. Actually, let's go back and forth. So if we look at this is the GitHub action file that's being run. The first thing it's going to do is it's going to make a call to get token. So we can look at that code. So somewhere in here is get token, which is here. So it's going to generate a random 32-bit string. It's going to create this token object. The status is unvalidated. We have a time. We don't have a code, but we do have, sorry, we don't have an identity code, but we do have a token code. It's going to save it, and it's going to send us back this token code. So we have a token. Cool. So in this part of the code, we save the token. So we generated a token. Then we have this, it's going to save. So this is in GitHub Actions. I think this is a deprecated way, but you can save variables to be used in a later step of the pipeline. So we can see we're echoing SD talk to here, and there's an output called SD talk. You can see it here, and actually in the next step, I grab SDK info output here. So that's how you save output. So the next step is this SDK identity. So it's going to make another curl. It's going to go to the get ident route, and so we have that token we passed. We have our repo name, and we have a run ID. And so these are supplied by GitHub. That's why they start with the GitHub thing. And so if we look at this code, we're looking at get ident, which is this call. It's going to parse the URL. It's going to check and make sure all those 3 query parameters are there. It's going to grab the token code. It's going to make that token code, make sure that token code exists. So that was from the previous call. If it does exist, cool. Make sure it hasn't expired. I think we get 120 seconds. And it also checks the status to make sure it's not expired. Cool. We're going to grab the owner name, the repo name. We're going to generate an identity code. So we have both a token and identity code. And it's going to save a bunch of stuff related. So there's the identity code and there's the identity object. And so the identity object, so all this code is trying really hard to make sure only GitHub Actions can ever actually download the SDK. So anyways, we have this identity object, and it's going to relate all these different things. So the identity code, the token code, the owner, the repo, the run ID, and the time creation, and it's going to save all that stuff. And so now we have both a token code and identity code, and it's going to send it back to us. And so remember, what's really tricky about this problem is it relates a run ID. And so this is the GitHub thing. So once a action has started, it has a run ID, and somehow we have a identity code and a token code corresponding to this run ID, and that run ID is already started. And we also have obviously the owner and the repo name. So tricky stuff. So we get back a identity code. A lot of different codes. So now we have this identity code, and it's going to echo this into the logs. So server ID, and then that identity code we just got back. Cool. Then this job is done. The next job is going to start. We're going to get site name. We're going to get back that token from the previous one. Then we're going to do check identity. And so what this is going to do is it's going to go into the logs. Actually, just take a look. So we have the URL. We're going to get back a token. It's going to load this token object. It's going to make sure it hasn't expired. From the token object, it's going to get our identity. And then it's going to do this get repo identity. And so overall, there's a bit to this function, but basically what it's going to do is it's going to look at the logs for the run ID, and it's going to look for this specific line. Where is it? This specific line where server ID is equal to this. So you can see we're already constrained pretty tightly. Like, we got a token, we had to supply a run ID, a repo name, and a token name before we got an identity, and then this identity is echoed out in the run logs. So you can't just like interact with this code by yourself. And there's even more constraints. So this is going to call out to the GitHub API. It's going to find the job. It's going to get the logs for the job. It's going to split all the log lines. It's going to just skip a bunch of logs. And then it's going to, like I said, it's going to look for that server ID within the logs. And it's going to get what the actual ID was. It's going to make sure you're not running it in debug mode, because I think that prints out a bunch of useful information. Specifically, it prints out, I think it makes it really easy to stop the job halfway through. So it makes sure debug doesn't exist. Then it's going to veriflow the workflow file. So what it's going to do is we're running that build.yaml file. It's going to download that file. Headshot, it's going to download it. It's going to take the hash of the code that's actually running, and it's going to make sure that the hashes exist, or equal. And so this is the tricky part for me anyways. At first I was just going to modify this, and I was be like, yeah, don't delete the files and just upload a new artifact. But it actually takes a hash of the file and make sure that that hash matches this one. So we can't even modify this file, which makes it difficult. And if all that matches, it returns the identity from that echo call. Whew. Cool. So if it is okay, it's going to let us know that it was okay. And then at that point, we can then do the final call back to the web server, which is get, let me actually go back. That wasn't the end. At the very end, it says token validated. Yeah, so we get back this repo identity. So this is the one that was parsing the logs. It's going to make sure it's not undefined. It's going to make sure that the codes match. And then it's going to set our token to status to validated. So then on the next call to get SDK, it'll parse the SD token. It'll make sure the token's real, it'll make sure it's not expired, it'll make sure it's validated, and if it is validated, it'll then expire the token and send back the CoolSDK. And then it'll delete some stuff, and then it'll actually run make, and it'll build the actual executable. So I spent, again, a couple hours on this challenge during the CTF. I had a couple different ideas that none of them obviously worked. The first one was you can create your own GitHub runners. So by default, it just runs on some Ubuntu VM hosted by GitHub. It's free, it's nice. You get X and X credits per month. I thought it'd be cool to, maybe I could install my own GitHub runner on some, Ubuntu and EC2, and then I could just see what the files are, because I don't think the files are deleted. The problem is, I think to do that, you have to modify this file somewhere. Like I think you do on, it runs on, and then you would give the name of your runner here. And I can't modify this file because that would trigger that hash change. So that didn't work. Like I said, my very first thing was just modifying this, and then I saw the hash change. I also tried doing what Strelic was doing, which was turning on debug mode and canceling. I couldn't get the timing right, so I figured that wasn't the exploit, and I just got frustrated doing that. But I guess that I should have just continued out on that path because he got it to work. What else did I try? I tried to get more logs. One of the tricky things is they echo the server ID, but they don't echo the token. Yeah, this token goes into the GitHub output, but we don't have the token. I think if we had the token, this exploit would be a little bit easier. But I couldn't figure out a way to get the token. Oh yeah, like if you can run this job and know what the token is and then run this job, I think it's possible to do an exploit, but I couldn't get it working. Now that I think more about it, I think I understand Strelic's solution a little bit better. I didn't realize you could pause and rerun a job ID. But anyways, we're not going to talk about that solution. Yeah. So yeah, couldn't get anything to work. And then of course I was looking for bugs in index final. Thought maybe we're just, it's under web, so maybe it's just like a generic web challenge, and maybe there's a bug in here like a type confusion, or we're overwriting some stuff. Maybe there's like some prototype pollution or something, but couldn't find anything. So like the two people in Discord said, the solution was to rename your repo. And so that's what we're going to do. So if we start here, this is the solve script that I was using. So here's the site name. Basically, I just copied out the code in here and modified it a little bit. So what we're going to do is we're going to grab a token ourselves. Then we're going to get a run ID. I'm going to run through this code. We're actually going to do the exploit. It takes a good minute to actually do. So we're going to start a run ID, we're going to grab a run ID, and then we're going to cancel it immediately. And so that way we can reuse the run ID, which I think this is the trick I was missing for the exploit that Strelic did. But anyways, from there, we're going to then run and get out for this token a identity, a server identity. Then we're going to rename our repo to the server identity. So in my case, like right now it's Conrad MyCool Encryptor or something like that. So we're going to instead rename it to Conrad server ID, and then the actual token, which is pretty interesting. And so when we rerun the job, somewhere in there in the logs, it actually writes out this line, because of GitHub repo or something like that is somewhere in the logs. And so it'll parse this one before it parses the real job. And so really there's like we're doing two different workflows on the SDK. We're doing one in this bash file, and then one is also happening in the GitHub action. And we're kind of abusing both of them. But anyways, we'll rename the repo. Once we've done that, the run, we restart the job within GitHub actions. So that way when we do check identity, it's going to check that run ID, the repo, and the token and all that stuff. And it's going to grab the very first server ID, which will match with ours because of the repo name. And from there, we'll have a valid token that we can use to download the file. Anyways, let's see if it works. So we need to make sure our repo, nothing too exciting is going on. Cool, everything's good. So we're going to run solve. Oops, where are we? Let's go up one. So start, I have some comments to myself. So start a new run with MyEncryptor, then stop it immediately. So we can go and start a run. So we're under GitHub Actions. Under my repo, we're doing build MyCool program was the name of the run. We're going to run this workflow. We're refreshing to see where the job is. There, it's queued. We're going to cancel this workflow. We're going to grab this run ID. We'll give it to the script. Cool, then we're going to rename the repo to this. So we're going back to settings. It says it's available, we rename. We can see this is now our repo name. We're going to go back to this job. Thankfully, when we rerun jobs, it's going to use the same run ID. And so now we have this new server. We're going to rerun all jobs. Cool, and then we need to wait for this to finish. I think for this whole process, we only have 120 seconds. Once this is done, I think then we can run the rest of the script. Let's refresh. Cool, it's running. We can look at the logs. So we can see, yeah, the job is defined at here. I think it actually waits. Oh, my mouse is dying. There we go. We can see that was the real server ID, but obviously we don't want that one. Yeah, that's the real server ID, which I think is different than ours. Yeah, because we're looking for G2L or whatever. This should fail because it's going to parse out the wrong server ID. Yeah, so it found GL2, which is good. That's the one, but it expected this other one because it's doing a separate run. Anyways, it failed. It's downloading. Cool. And we were able to download the SDK. Normally it would have failed, but thanks to our clever exploit, it worked. And then the rest of the challenge is pretty easy from here. So if you go into CoolSDK, there's 3 files. There's this. Actually, let's just take a look. MyCoolSDK. So there's some giant matrix. There's some encrypt function. Does a bunch of XORing and adding and a bunch of stuff we don't really care about. There's some decrypt function. So these are the functions that we needed. Missing. Nothing too exciting. There's a header file. Cool. This is the README for that CoolSDK. Encrypt all your data with this CoolSDK by a cool guy. And then here's some tests to decrypt with. This looks important. And yeah, so at this point we can actually just build the program and then we can try decrypting this string. So let's go into MyCoolEncryptor and let's move that SDK we downloaded. It was up cool. We need to do it recursively. Oops. Actually, I don't think we have to do it recursively. It's a move. Cool. And then let's go up one. We're going to do make Ubuntu. We're just going to jump into an Ubuntu machine real quick. Then we're going to do MyCoolEncryptor. Then I think this is the make file we want. Yep. So we're going to make the encryptor program. Cool. So we can now run CoolSDK. Oh, sorry, CoolEncrypt. Cool, it gives us 2 options, encrypt or decrypt. Let's try decrypt. We have this message already in the GitHub repo. It's split on 2 lines. So it's supposed to be that way? Not sure. We'll run it like this. A numeric key. Oh, maybe that's the numeric key. I was doing it with 0, and we still get out the flag, which is here. So, whoo, my SDK wasn't so private after all. Maybe this is the one, though. Decrypt. It was missing an iris, so... Oh, there we go. I guess I was supposed to use 69.420, which makes sense. There we go. There's the real flag. I guess it doesn't really matter. You just missed this iris part. But I was just by default going to add it. So anyways, there's the flag. Pretty fun challenge. Yeah, definitely frustrating. I was definitely frustrated during the CTF. It seems deceptively simple, but yeah, it was pretty complex. And which you could see, only 2 people solved it. So congrats to those 2 people. I guess if the challenge, I mean, obviously the challenge author wrote vulnerable code, but I was thinking about, like, as a defender, what you would do to fix this. And I guess you could check the repo identity. So I think we save the repo name, but we don't validate it later. So I guess that would be one fix to this if you really want. I don't think you should hide your SDK in a GitHub Actions. But I guess that would be one fix. So then maybe stronger parsing of the server ID. But anyways, fun challenge, and thank you.